have your Deep Well of Time book, there is a story about square root. And it has about 17 times more words than necessary to tell the story of a square root. But it's nice to, I don't know, you can get some information from here and then kind of share the pieces that feel relevant to you. So, this is a great thing because they're easy to grow in your garden. What am I holding in my hand? This is a radish. Thank you for using your imagination. This is a radish. And it gets its name from an Italian word that comes to us from Latin radis, which means root. And so I'll usually draw a radish, and it might look more like a turnip, and you know what?
It's all good.
That is not why I got hired for my... So this is a radish, right? And a radish is a vegetable. And it gets its name from the Latin word radis, which means root. And a radish is really like a root. In fact, it is a root. And so I could draw the ground here. A radish grows underground. And so it's the part that we eat is the root. It's the part that's underground. So around the 1100s, some people were thinking, just as people had thought before, that some numbers have roots too. Can you imagine that a number could grow a root and be like a radish? Well, in fact, a number can grow a root, or even better yet, many numbers grow from roots. We're going to be talking about roots, especially number roots, a lot more. There was one special root, the square root of a number, which was interesting to many, many people. Now, I want you to remember one thing as we talk about roots, that the word radish comes from the word root, and they both start with an R. And I have some little cards available. So radish comes from the Latin word root, and they both start with R. And a long time ago, whenever they were writing the letter R, this is how we see it now, but there used to be this little tail on the R, and you can see how that maybe looked similar to the symbol for the square root. Early mathematicians believed that math was integral in nature. A plant wouldn't exist without a root, its lowest part, and in the same manner, a square could not exist without its lowest part, the root. And so, look at this. Okay, that's like the same thing I had there. All right, and so when we think about square root, we're looking at the lowest part of a number. So here I have my 2 square, right? And if I were to hold it up and look at the bottom here, that would be the square root of our 2 square, because there are 2 beads down here. And I would actually have my square, my 2 square. The only reason I picked 2 squares because I happen to have a green thing in my hand. Usually I use like a 4 or 5. So anyway, with some reading this story ahead of time and really thinking about what I wanted to say, that would have been a lot better. But we start looking at the square root. So how many beads are here?
4 total.
There are 4 beads, right? 4 total. And so if we're wanting to find the square root of 4, we have this symbol that represents the square root. And each of these parts has a name, just like in division we learn the parts of a division problem. We can also learn the parts of a square root. So this symbol right here is called a radical. And inside, the number that's inside is called the radicand. Can you say that? Radicand.
Radicand.
And the answer in a square root problem is the root. So lots of R's all around, aren't there?
Mm-hmm.
All right, so we're going to work on finding the square root of some numbers. And I brought along an old friend, the test tubes, to help us out with this. I also have this little box down here and it has unit beads in it. I find that to be a little bit more cumbersome than just grabbing the test tubes. And so let's say we wanted to find the square root of a number. I'm going to pick 49. So with my test tubes, this is really easy. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. So now I have 20. 2, 4, 6, 8, 10. 30. 2, 4, 6, 8, 10. 40. And if I have one left in this, there is 49. And so if I want to find the square root of 49, I want to see what is the biggest square I can make. And when I make that biggest square, the number of beads on the bottom will be the square root of that number. So I start up here at the top corner and I'm going to place one bead. Now I make the next biggest square I can make. So now I have a 2 square. I can keep going because I still have beads left. And you can see I'm going, like I started up at the top left, I'm going left to right, top to bottom. Now this is a 4 square and I still have more beads, so I can keep going. Now we are at a 2, 4, 5, 6 square. This material is called the square root board. That is all my beads. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. The root is what's along the ground. There are 7 beads here, so the square root of 49 equals 7. And at this point, we will just practice finding the square root of different numbers. They'll use the beads and set them up. And I usually, so in, in division we have remainders, right? Remainders and they're like a fraction of what's left.
Mm-hmm.
When we're finding the square root, it's not quite the same. So, I mean, we'll still call it a remainder because it's what's left, but just be aware that it is different than a remainder in division. I actually watched a video on Facebook because that's how I spend all my free time, is watching math videos on Facebook. And they talked about a way to figure out what the remainder is, and now I don't remember it. I'll have to watch it again.